right, so what we're going to do now is we're going to take some real life equations and we're going to put them on a graph. Okay, so let's take a look. We got Georgie is joining a gym and she's paying $25 to sign up and $15 for each month, okay? So let's come up with an equation. So X, will make that the months, right? And then Y, we'll make that the cost, okay? How much she's going to wind up paying. And I'm going to put this in slope-intercept form, right? So Y equals the cost. Okay, she's starting off with 25 bucks, so that's her starting point. And she's paying $15 for each month of going to the gym, right? So if you look at our graph here, the x-intercept again is going to be the months, right? And then the y-intercept is going to be the cost. Now you'll notice I'm only going to focus on quadrant 1 because we're not going to have any negative values. Okay, the months, so she's starting over $25, so we're not going to get any negative money, right? And it's only going to go up. The slope is positive, and there's no such thing as a negative month, so we're not going to get into any negative numbers here. So if you look at the months, we're going to go by, I would say we could make our increments by ones, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As far as the cost, I'm not going to go by ones because we're starting off with 25 bucks, right? So I would say maybe go by fives, all right? So we're going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Again, that could change. You could even go by tens. All right, so that's really up to you how you kind of want to go with your increments as far as the money, okay? So if we're going to start off with 25, right? There is my graph here. And we're going up. The slope's going to be 15. So we're going to go up 15 over 1, right? So 5, 10, 15 over 1, right? 5, 10, 15 over 1. Kind of ran off the graph here. All right, so that's kind of what my line looks like, right? So if I put another one, I guess that would be 55, right? Now, if I used the graph to find a solution, all right? So let's say after 1 month, right? So after 1 month, if I use my graph to take a look, after 1 month, we're talking about 40 bucks, right? Now, it says how much would Georgie have to pay after 5 months? Well, 5 months kind of ran off our graph, didn't it? So if you kept going with the graph, we could also do this. We could plug in 5 right here, couldn't we? And 25. So if I probably went up a little further on the graph, 5 months is going to be $100, okay? Now, I think if I went by 10, you'd probably see it on the graph where I went up to 100, okay? So basically, that's what our graph's going to look like. You want to look up here, and again, notice that nothing here, this quadrant is not going to be used. The only one we're going to focus in is quadrant 1, okay? And that's what most of these word problems is. You're going to deal with quadrant 1. Let's take another. Now look at another one. So we've got what do we got here? We've got Edwin, and Edwin has $50 in his bank, and he starts spending $2.50 each week on snacks. All right. So what we're going to do is figure out the cost. So again, I am going to use Y as the money that I guess Edwin has, right? Or he has in his bank. And I am going to use X to represent each of the weeks, right? So my equation, if he's spending now, he's spending $2.50, which would mean that he is going down to 50, okay? And he started off with what? 50 cents, right? So let's take a look at what this is going to look like. All right. So now, I forgot my X value there. I actually, $2.50, if you look at it, I would really want that. I like my slopes and fractions. So if you think about $2.50, it's a negative. That would be 2.5, right? So 2.5 is a fraction. 2 times 2 is 4. Wouldn't that be 5/2? So I am going to actually change my slope to a negative 5/2x. Okay, just because I like to go down 5/2. All right. So that $2.50 I just changed to a fraction. So if I can, I'm going to change my slope into a fraction. All right. Now we're going to get it on the graph. Now you remember that we said the X was the weeks. Okay. That's the number of weeks. And then we have the money over here for Y in his account. All right, now I'm going to go by twos for the week. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Again, there's no set way. Just kind of want to get everything on your graph. And I think, again, maybe I'll go by 5s with the money. All right. So I'm going to go by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right. Now, the most important part, obviously, is the y-intercept, which is 50, and I just got it on my graph. So there's my y-intercept is 50. Okay. Now, again, I change my slope into a fraction, which I think is going to make it a lot easier for me because, look, I'm going to go down 5/2. So there's my first one, right? Okay, down 5/2, down 5. So this is working out really good. So I chose, I think, some good numbers to work with my slope, right? Down 5/2, down 5/2, okay. And then you'll notice right here, is the end, right? So I've got my line here. All right. So let's answer some of these questions here. I'm going to use my graph to find a solution. So let's say you could choose any. So let's say after 10 weeks, right? So after 10 weeks, how much does Mr. Edwin there have in his bank? Well, we'll look at his graph. After 10 weeks, we'll follow it up. Edwin has $25. So at 10 weeks, Edwin has 25 bucks. Okay? So I guess that's about halfway down, right? Start off with 50, now he's got 20. Now I'm going to read the graph. Question number 2 asks me, how many weeks will Edwin run out of money? And how is this shown on the graph? Well, the money here, that's the origin, right? That's when he's at 0. And actually, that's the x-intercept. So if you look when he ran out of money, in 20 weeks, Edwin is broke. So maybe he's going to have to call his parents up and get some more money in that account so he could get some more snacks at lunch. All right, so again, these are real world situations and graphs, okay?